Well, welcome back to tutorial 2, second part. So we already know that what we're going to do in this case, the NACA 0012 airfoil, and we're going to play first with, here we're going to use different background meshes just to see the influence and to show you this technique now that will help you save memory, time, but also get better meshes by using also small surface refinement. But also we're going to work a little bit in boundary layer, but a little bit, no, a lot in boundary layer, some techniques, very specific techniques that they might not solve 100% all your problems with the boundary layer that we know that is the main issue in Snappy, but it will help you a lot. So that being said, after this video, you can go back and revisit the cylinder, and when you reproduce these cases, probably you will see that in some cases you were having some problems, boundary layer collapsing, it was not growing, or very small values of boundary layer and you didn't have anything. So by using the techniques that I'm going to show you, you can come back here and you will see that you're going to fix those problems. Okay, so that being said, let's go and move to the tutorial. So you should download this tutorial. You have the link in the video description, and we go to M1, not the basic blockMesh. Then we're going to revisit all the cases. So far here we have the blockMesh dictionary. We haven't talked a lot about this, but there will be a video to address that, but take it as a template. So basically what we're doing here, everything has been parameterized. You only need to give these minimum and maximum dimensions in each direction to create the box and your desired cell spacing. So this one works uniform cell spacing. Then I have more complicated dictionaries for blockMesh to have the non-uniform, but do not worry about that. Honestly, I don't recommend to use a stretching here. It's very, very complicated, very tricky to use, and is using the other techniques that you're going to see, you're going to get similar results. So why these dimensions that I put here? So remember that I always like to generate my geometry. So I have it on shape, and this is how my domain looks like. So the box in blockMesh corresponds to this dimension. So you click there, you will see that I have my dimensions, and just put it there in blockMesh. Okay, and you have the dimensions. Some people might like to use some circular domain and so on. So that is also possible to do in blockMesh, but maybe it might be better using some other workflow that you're going to see. One of the workflows that we're going to use might solve that problem. And so you can use arbitrary shapes for that background mesh, or you can use an external tool. Doesn't matter. Okay, so let's work in this case. And okay, you have the blade here. And what we need to do, so we know the workflow, no? So in this case, let's do since it's straightforward. So you have the dictionaries. I'm not going to go into details and talk about all the options and so on. I'm just going to go right ahead to what we need to modify. So here you have, let me open this one. So this is going to run the block mesh. So we know that we have the uniform mesh, nothing to talk about that. And here we generate the mesh. So let's generate the mesh and generating the 3 steps. Okay, so let's see what happens here. Okay, so very straightforward case, run mesh all. And this is what we have. You have your mesh, you have your 3 steps, everything is perfect. So remember that working in 2D, we're using the extrusion and so on. Okay, so we already visited that in the previous case. And let's look at our mesh. Okay, so to the here, go here. So remember your 3 steps. So you have a step 1, we go with edges, the Cartesian mesh, then the body fitted, and this is okay. But the issue is that look at the curvature. This is resolving nice, but it's not very well resolved. And then you have the boundary layer. Here you have this issue that kind of the collapsing, and this is in this case is difficult to control. I have to say, this is all the quality metrics now that are being checked in OpenFOAM, so it's doing that. It is enforcing. So one way to solve that one, I will show you a technique is more advanced, kind of adding a thin calc here to extend that, or playing with the mesh quality parameters that we're going to see later. But just to show you that, for instance, remember all these 4 cases that we have, we're going to use exactly the same surface refinement factor. Okay, so we're reading everything. Okay, so here I put many options that later, later video, we're going to see complicate things a little bit more. But the issue here, we have a refinement 4.4, okay, which is already high. But if I want to have something finer, and you will see that now it goes 6.6, and let me rerun. Okay, close here. It will be more time consuming, obviously, but also as you look at memory usage, it will use way much memory. And you will see you go to 8, and you have seen now how this octree structure works due to the power of the refinement level. And 8, very fast, it will increase your cell count. So as I say, this is a small case, so things will be fast as you go 3D since will start to work. Already 6 in my personal experience is too much. It's better to control. But look at what happened when we increase. We have better resolution. Okay, things work better. And even the boundary layer at the end is much better. It's not as large in the previous case. Still, you have something like this. My opinion is not a problem. So you need to learn to live with this kind of small defects. So it's in the trailing edge. It's not going to damage much the solution. It will be different if you have something like this in the trailing. Sorry, in the trailing edge. So you have something like this in the leading edge, probably will influence the whole boundary layer. You have transition to turbulence. It is a no-no, but it's not a problem. Okay. One thing that you can do to try to mitigate, okay, sometimes it will fix the problems. You go to mesh quality. What is doing OpenFOAM, snappyHexMesh while running is always checking all the quality metrics. So as you go here, you see the log file, you see that it's doing many iterations trying to enforce the quality metrics, okay? And sometimes might be the case that they are too low, okay, and it doesn't do anything, it doesn't manage. So one trick is just to disable these quality metrics, okay? It's not the best technique. Many times it works. You need to know how to adjust your pneumatics, okay? But you can give it a try. So you put it here, 180. You completely disable maximum orthogonality, negative values for excuses. You disable those values, and now Snap is not going to enforce that, and likely it will solve some problems now when it comes to boundary layer collapsing. It's not say that it's going to fix it in this case. And I have to say something here also. We're working on OpenFOAM 12, and there are differences. In previous version, OpenFOAM, I haven't checked it in 11, by the way, but in 10, there is a difference in the mesh generation. Exactly same case, you're going to see difference, and you will see that it works better in OpenFOAM 12. You need to use these specific tricks in this airfoil. As already know, it tries to get it will give you good meshes. Okay. So it seems now developers are working there trying to fix many issues. But we go here and kind of, as you compare, maybe you will see that there are some slight difference. But here you will see that it's just enforcing those quality metrics. So you will have no orthogonality excuses. Then you have one that is later we're going to see that is very important, which is the aspect ratio, longest size to the distant normal to the wall. Okay, that is very important, and some other extra that is going to give you those issues. But this is a sectoral mesh, not an issue. Okay, so at this point, feel free now to play with those options and just to come back here. But what I want to show you in this case now, everything crystal clear. We haven't done anything new, different from the previous case. So let's do something, okay? And we have this mesh. So we're using the same parameters, and let's reproduce all cases, no? So N2, we have blockMesh with extraction, okay? So as you open here, you will see that this blockMesh starts to become a little bit more complicated. Here's where you have all the stretching options, how to act that stretching in the mesh, which pretty much will be this stretching. Then the technique 2 is we use refinement. So N3, you go here, and here you have all the steps that we follow. No, this is the blockMesh. So basically here we're using a combination of topset and refine mesh to do refinement. So first we use topset, Okay, so I'm not going into details. You can open that. Okay, try to reproduce the results, generate one step at a time. So we're going to do a selection of cells in the mesh, and then in that selection, we're going to apply a refinement. So here you have the refinement dictionaries here, and basically we apply this refinement in this direction. Here, by the way, you have also commented. When you see the file commented, you will see some comments there. So basically, this is what we're doing. One toposet, we have a mixed size rectangle, then the other toposet to get the small rectangle, and we use a different refinement in that region. Then also we can add this one for the large one. So it's up to you. I commented here, but this is this technique. As you can see, this technique is a little bit complicated. You have this toposet and also the refinement mesh, this utility refined mesh is difficult to control when you have let's say crazy geometries, no, because the opposite you can use it for squares or circles, and sometimes with circles it's difficult to control, but if you have some arbitrary geometry, this is not going to work. Okay, even if the opposite can read STLs, it's difficult to control. It's better to use the older technique. Okay, so it will work. It has limitations, probably a little bit confusing. Okay, but you can take this approach. Okay. So let's see what's happening here. Okay, so if I go here, run mesh, and I will do just the block mesh, okay? It will follow all these steps. It will do all the refinement and so on. And when you look, this is what you have, okay? So mix size, and there was the large one that I disabled that one, and then you have the small one. So basically each of these refinement is a refinement of one level. You can see here that you go background mesh, cell size is 0.5, then refinement one level 0.25, and then the other refinement one level 0.125, and that's it. And now when you put the airfoil there, you will use the cell next. So very important, remember, okay, let me go, what is happening, that now you have this background mesh here, geometry, and let me put the airfoil there, apply. This is what happened. So you have a smaller cell, and with a value of 4, now you're going to resolve better curvature. You are going to avoid to use a lot of memory. So these are the techniques that you can use, okay? So by no means you need to use these tools. You can use an external tool, okay? So there are a few open source that can do very nice stuff like this very fast. It's up to you, okay? So you have this technique, okay? And now let me show you the one I like to use, okay? So it will be M4. So this one is a little bit more complicated because we're using a snappyHexMesh to do that. So let's go into Open M4. Okay, and here you have background mesh. So there are some steps that you have to be careful. So see that, okay, this is what we're doing, okay? So basically blockMesh, you create your background and then you use a snappyHexMesh to do that arbitrary refinement. Okay, so see that we're reading a specific snappyHexMesh. So the blockMesh is the same one, the standard one, but I have here this blockMesh. So remember that in blockMesh, we can do region refinement. And not necessarily we need to read the STL. So see that here, I'm not reading the geometry of the airfoil. I'm just reading, or I'm using some internal entities, or you can also read an STL that can represent, for instance, it can be the STL of this domain. You read it, and what you're going to do now is that these entities that you created, no features, no surfaces, just region refinement. And remember that snappyHexMesh, it is a X dominant, so it's going to do that refinement. No, all the cells inside that region will be X's, but then you have the transition, and that transition between the smaller and larger might add some pyramids or polyhedron, general polyhedrons, and so on. But inside where you're going to put your body will be excess. So this is what we're having. By the way, look at that, what happened, where we have a cylinder there, you can rig an arbitrary shape, and the rest, nothing changed, okay? You need to, by the way, look at that here, we only need to do the castellation. All the refinement, remember, is done in the castellation. Okay, so this is what we're going to do here. So if I go here, run mesh background, it's going to do that, your blockMesh, and then just add the refinement. At this point, we should have the background mesh. And this background mesh is the one that we're going to use now to do now the body fitted mesh. And this is it. So as you can see, this is much easier than the previous method using topple. So if for some reason you want to use topple and refine mesh, stick with this one. But my personal opinion, this is much better. To point out something as well, in previous versions of OpenFOAM, there were, okay, here we start to see the transition. Just I want just to show you that. Okay. These are the cells that I put here. Okay, so see that how is transition, and also snappy when you transition from small to large, it will try to fill this, no, here using some shapes, arbitrary shapes, no, tetra, pyramids, polyhedron, but it's just in this interface. It's not going to do it internally, okay? So an advice, try to put those regions a little bit far from the body, because as you start to grow, no, the mesh here is going to give you problems, okay? So that is the only warning that I want to give you, and just to put the geometry there. Okay, so as you made that circle and you make it too close to that, when you grow, you know that you're going to put a refinement there, and when it grows and then it enters there in this shape that is not an NACA, it's going to give you a problem. So remember that all the refinement here in Snap is done based on the idea that you use this octave structure. No, you take an X and you split it into 8 or whatever you, according to your refinement level. So be careful about that. But for the rest, as you can see, you can use arbitrary measures. So whatever you put your body have to be hexa dominant, and then outside you can put tetra, poly, whatever you want. And this is it. This is the technique. Okay, this is the one I like to use. To give you a warning here about when you do this, okay, and let me give you a link here. So you have a README file here, and you have this link, okay, comments about some extra files. When you use this technique, Snap is going to generate some extra files. Okay, so you go here, and here you have the comments. Okay, so this extra file, set level, point level, level 0, whatever, you need to erase it now, because this is information that you need to do some refinement. As you are doing some adaptive mesh refinement, you need it. Okay, so when you move to the next step using a snappyHexMesh and you leave those files behind, it's going to give you an error. So look at that here in the script. I'm erasing cell level, point level, level 0 edge. Now, so in these files, you're putting information related to the refinement that we don't need for this case. Okay, for this technique that we're mentioned, we don't need it. Okay, so bam, 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 bam. Go here and polymesh. Surfacing this, you have that information there. Or so recommended. Okay, so already erased it. No, that information. So that is the only warning. Okay, so now let's do the whole mesh. From mesh. Oh. And basically you have this grid. And remember that in this grid, those files are being removed. Okay, so very important, removes. If you comment these lines, you will see that it's going to give you an error. Okay, so basically it's related to that link. No, that update. So after you generate your background mesh, so you convert in this case is 2D, do the 2D conversion. I do some scaling there, okay, just to make it unitary, I think. Erase the files, and then you move to the snappyHexMesh. So you have your background, snappyHexMesh. I save in the intermediate steps, and that's all. So I have a few non-orthogonal cells there, but it's not a big problem. And already saw a video that you can remove those cells. It's not recommended, but you can give it a try and see what is happening. And see here. So exactly using the same refinement rate. So by the way, here I have parameters. Okay, these are not the default parameters that I'm using. This is part of another technique. But see that, and for those that say that you cannot generate very fine boundary layers, see that this is very fine. So this is the trick, but I was playing around before, so let me go back and update this, and also you will get the right values. So basically nothing changed. So see that now here you read the STL. Okay, you have extra files, and then I will show you. So see that all cases level 4, nothing changed, everything commented later. This point outside of the airfoil, using my default values. Okay, as I mentioned, for 2D cases, it's better to use the implicit feature as NAD. Okay, in 3D, use explicit, so you use surface features. And here we have these options. Okay, this should be 5. This is 5. Okay, nothing here, standard options, and we're done. So let me go also to mesh quality. Okay, bam, bam, bam. Let me also add a comment here. Okay, I want to use the default values or the conservative values. And let's redo here. Okay, now go here, add a font to D, and there you go. Okay, a very nice mesh. Okay, you control very well your refinement. And this is my preferred technique. So now let's do something. Let's generate all meshes. Okay. So here you have the script run all meshes. It's going to do all cases and one and do. Let's do the comparison now just to end this video. Then we move to another to show you techniques, some other tricks, some other standard practices. Okay. So by the way, you can also run this case in 3D. I put it in 2D just because it's fast, as you can see, but you do it in 3D, nothing changed. Okay, same technique. Okay, so let me go load state. Let me load this one. I want to load this. Okay, and there you go. We have the 3 meshes. So here we see better what is happening. Okay, remember all cases, surface refine. We have exactly same options, surface refinement, and look at what happens. Okay, so if you want to get a good surface refinement, like for instance in these cases, for this background mesh, you need to increase the refinement, okay, by a lot. Or the other option is to have a much smaller background mesh in all the domains. So to avoid that, you can add stretching, or you can add local refinement like in this case. So here we added local refinement using top-offset refine mesh. Here we use the technique with the snappyHexMesh, which is my preferred technique. Okay, so this is the way I recommend you to do it. It's much easier. Okay, and it's a very, very straightforward workflow. So there you go. Okay, first technique, first trick. So I think this will make your life easier. So instead of going and increasing the surface refinement to crazy values now that I have seen, and probably in the beginnings when I was a first user, also I was increasing surface refinement to crazy values like 8 here. Instead of doing that, add local refinement, and that should solve your problems. Okay, so this is it for this video. The next one we're going to see where I'm going to add some complication in these cases. So see you next video. Bye.